All right, so we have a -3 and a 7 will get the job done. All right. And actually, I mean, you could look at it and say, well, I no longer have to think. This is wonderful. I'll just do the next one and the next one. At some point, you want to take some time and try to reason it out. Go to the calculator when you try to reason it out and you still don't have it. All right. Or, you know, like you practice these skills in class for homework and things like that, but day of the test, you're like, well, I want to make sure I get it all right, so I'm just going to do it on the calculator. All right, that's fine. Regents exam, same deal. All right. So, yeah, either way. Anyway, -36, if you're looking for factors there, I mean, first thing that pops in my mind is 6 times 6. That's not going to get me to a 16, right? 9 times 4, same deal. 18 and 2. That looks like something close to what I want. All right, so let me put an 18 here and a 2 there. Now, this is only going to work if the 18 is negative, right? Well, if the 18 is positive and the 2 is negative, then I'll get a positive 16. All right, but again, the same deal, because I reasoned it out. I said, okay, 6 by 6, not going to work. 9 times 4, not going to work. 12 times 3, not going to work. 36 and 1, and so on. If you don't want to do that, then y equals -36 over x. Go to your table and start scrolling. All right. -6. Well, we could look at a couple of possibilities to get to a 5. We might say 1 and 6. We might say 2 and 3. All right, so let me try 2 and 3. All right. Let's assume that this is correct. Well, 2 plus 3 will get me a 5, but will 2 times 3 give me a -6? No. Now, I'm already at a point here. If it's 2 and 3, I know it's going to give me a 5 if I add them together. If I change the sign on either of them, I'm not going to get that 5 anymore. So in order to get the product of 6, I can't have a +2 and a +3. So that's an issue. 6 and -1. All right, so what it tells us is that 2 and 3 was not a good option. And what a lot of people will do is that they'll look at that and say, well, 2 and 3 didn't work. All right, flawed problem, or I just don't get it. It's all over. It's not factorable. They don't even consider that 6 and 1 is a possibility. All right, so if you're in a jam, go to the calculator. Don't be afraid. It's perfectly fine. All right. The problem's at the bottom. They ask us to find the product of the following binomials. All right, I'm just going to do them really quickly. Quickly doesn't always mean correctly, unfortunately, so and just do a quick double check or Ruski here. I think it's all right. My spidey senses are telling me that I did it correctly.
Just go over how you do it.
You double distribute. All right. The act of distributing isn't really what the focus of the problem is. It may seem like it, but it's really the observe any patterns. So we have two numerical terms here that make up each binomial. middle term here seems to be the sum of those values. And that appears to be the product. This is a relationship that's only true when the coefficients of x are equal to 1. So we'll have to adjust our thinking on this down the line, but at this point we can say that if we have binomials that are of this form multiplied, that we can just identify the sum of these two values, that'll give us the middle term, and the product, and that'll give us the end term. That's good for actually multiplying binomials. It's a nice little nifty shortcut. The issue is we need to turn it around and use that idea to help us come up with the factors, all right? So what that's telling us is that all that stuff we did up here with the x's, that wasn't for nothing. Because what I need when I'm looking at a trinomial, if I'm gonna put it in its factored form, so undistribute, is I need to find some pair of values that add to this middle number, but multiply to that end number. All right? So if I were drawing this out with that whole x business, I would have the 21 on top and the 10 on the bottom, and I would be asking myself what these two are. 7 and 3. All right? And so once you identify those, it would be x plus the first entry, and then x plus the second entry. All right, and sometimes those entries are negative, so you might have a plus negative, which would make it minus, but that's actually how you would go about factoring if you wanted to use that triangular approach, triangular region approach. So we're going to tackle some problems in a minute, but there's some other things that we have to investigate also. Some little nifty relationships here. So every trinomial that we're looking at is going to be in the form of ax squared plus bx plus c. But at least in the early goes, we're only going to focus on cases where the leading coefficient is equal to 1. So instead of ax squared, it's just x squared. All right. If it's in, and this is really just rote memorization, you just studied it. Your possibilities, if both signs are positive, when you factor, your factors will only be made up of positive values. All right. If it's negative and positive, then both parts will be negative, and so on. So you can read through this and study it. But if you go by the numbers, all that stuff is going to work itself out. So this is kind of like an added luxury or a bonus. Like, I already know how to do all this stuff, and I have some more time on my hands, so I want to investigate different relationships. Those are some other things that you can look at. But when you're actually just looking to factor some of these guys, it really is just a matter of saying, all right, it's a trinomial, all right? And very important, you still have that progression. It's still, is there a GCF? In this case, no. Is it a difference of 2 squares? Well, it can't be because there's 3 things. All right? Is it factoring by grouping? Well, there's 3 things. I don't see how I'm going to split it down the middle if there's really no middle. Like it would be two terms and 1 term. That's not really splitting it. All right? So if there's 3 terms, it's going to be a trinomial factoring situation. So we're looking at something that's going to be in the form of x plus something times x plus something. We just got to figure out what those somethings are. All right, so the one way that you could do it would be to do that x chart. This is our c value. That would go here. And our b value would go here. All right, the c value is where it all starts. That's why it goes on top. That's the most important thing, because that's going to give us a set of possibilities to work with. We need values that will multiply to 7, but also add to 8. Now, if you were to go the other way and look for all the ways that you could add to 8, and then narrow it down from there, you're wasting a lot of time, because there's infinitely many ways that you could add 2 numbers to equal 8. All right, so that would be a big problem. So instead, we go the other way, because there's a finite, very limited amount of values in which you could add, multiply to equal 7. The most obvious would be, and actually the only, 7 and 1. 7 and 1. All right. So that's the beauty of prime numbers. If you have a prime number, it's 1 and whatever that prime number is. All right. So 7 and 1. And you could check by distributing, the double distributing. So x by 1. 7 by x, 7 by 1. And we would get x squared plus 8x plus 7. Now, just be careful because a lot of us like to do a check for questions like this, but you do need to clearly indicate what the final answer is. All right, because it is kind of misleading in the regions that they don't give the benefit of the doubt. If you do this and all of the stuff follows, they assume that the last thing that you wrote is what you're saying the final answer is. And you know, I know better because nobody would just rewrite the question as their final answer, but they're like, well, it's not clear, so minus points.
No matter which order you write those numbers in green, like can it be flip-flopped?
It could be flip-flopped, yeah. All right, so number 6. And I think this is probably the last one I need to do with you because it's just practice. I mean, just practice. It's good practice. Still the same theme, you know, slow and steady, but also if you get good at this now, you'll be rewarded for it down the line. All right, so 24. And you don't have to do the X thing if you don't want. In fact, it wasn't until I started teaching this course that I even saw this X thing. Because it was all, this is the way I learned it. It's like, all right, how can I multiply to equal 24? I get some numbers in my head, and then I start asking myself, okay, do those two numbers add to equal negative 14? No. Do those two add to equal negative 14? No. Do those? Yes, those are my answers. All right, so if you don't need the X, you don't have to do the X, because essentially you're doing the same thing, just in a diagram. All right, so what are we thinking? Negative 12 and negative 2. So it's really, I'll write it specifically and carefully. So the form is x plus something, x plus something. That something here is a negative 12 and a negative 2. So these would simplify, and you could skip this step, but I just wanted to show you how it all comes together. X minus 12. All right, now, if you're one of those people, and I was, factoring, I thought it was a standalone topic that didn't have any meaning. The teacher, I'm sure, said all the stuff that I'm saying, like it's important, you need to know it. But then I saw it, I'm like, how could this ever possibly be useful? So I zoned out like a lot and didn't pay attention. So I was one of those people that are like, all right, I'll just write it down now, but where's that negative 12 and negative 2 coming from? Because they seem to know it, they seem to know it. I don't want to ask because everybody else seems to know it. So if I ask, I'm going to look like a fool because it seems like I'm supposed to know it. Like the negative 12 and negative 2 just got written up on the board like it was magic. And again, the idea is that there's supposed to be two numbers that multiply to 24. So you start with that, and those two numbers have to then also add to equal negative 14, which is great. But then you get to the next level of that. What if I cannot figure out what those numbers are? You go back to this bad boy right here. Y equals, you can't ignore the calculator technique. Type in the 24, the number that you have to multiply to. 24 over x. Go into your table. Start looking around. And what I mean by looking around is for each row. Just say to yourself, all right, I got a -4 and a -6. Will those two numbers add to equal -14? No. -3, -8. Close, -11, but no. -2, -12. Yeah, right? That'll give me a -14. And so at that point I have it. How did I know to start here? I didn't. I hit second graph and it brought me right here based on the last problem that I did. All right? If I wasn't here, then I'd have to scroll to get here somehow. So maybe when I hit second graph, I get over here and I'm looking at this and saying, all right, well, I don't need that one, that's a decimal. 14, that's not gonna work. A whole lot of decimals over here, so I'm going in the wrong direction. 11, no. 10, no. 10, 11, no, no, no. 25, if I add them together. -25. Oh, there it is. All right, so eventually I would get there. But again, it really is the same as doing this, except you don't have to write any of this down. You just scroll through your list and see what comes up. All right, but you do have to do the mental math on the spot and say, what is -2 plus -12? Because if you don't do that, then you'll be looking at this and say, okay, I followed the steps, I don't know what I'm supposed to be looking for. All right, and we'll get to a point where the decimal values become relevant too, so that's also a challenge. But that's really the concept. I mean, in some questions I'll switch from X to M and K's, but it's the same structure, the same form, nothing's changing there. All right, so it's all the same skill.